Thank you and welcome. So today we're going to be presenting on building an on-premise hybrid API platform. Welcome, my name is David Freeman. I'm from a consultancy called Sonrai Consulting. We're an Australian-based consultancy and we're actually dedicated on helping businesses along on their API journey, whether that be building API programs, API platforms, or APIs. Effectively, everything API is our specialty. So today, we're talking about building on-premise hybrid API platforms because we've actually just finished building an on-premise API platform just in the last couple of weeks. So I thought it'd be a good time to go through this with you and give you some hints and tips and tricks if you're looking to build an on-premise API platform yourself. So who is this talk for? Really, it's for architects, lead engineers, or project managers, those people that have either built an on-premise API platform or are looking to build one. We think there's a few things you'll be able to get out of this. But before we get started, there's probably a few things we want to get out of the way before we start talking about how we delivered an on-premise API platform. So one of the obvious questions is, well, why would you build on-premise when there's so much cloud? It really doesn't make any sense. Everything's going cloud first. But there are actually some very good reasons why people build applications on-premise, and API platforms being one of those. The first one is regulatory. Perhaps you've got sensitive information. Perhaps you've reviewed the terms and conditions of cloud providers, and it looks like it might prevent you from putting your data on the clouds. And this is certainly true for a lot of financial institutions. Even though the clouds might say, hey, look, you can put your data here, there's still a much easier path to be able to keep that data, that personally identifiable information, that financial data on premise. So regulatory reasons are still a strong reason for building API platforms on premise. Location's another thing as well, and the cloud's not everywhere. We've all heard about latency. If we have to wait more than 3 seconds for a TikTok video to load, we're swiping next. Well, APIs, they've got an attention span like a goldfish with ADHD. So if you're not getting a response within milliseconds, it's like those APIs don't even exist. They might as well be down. So if you think about response times in milliseconds, if you're running a business in Perth and you have your API platform on one of the clouds, well, that's going to Sydney or Melbourne. That's going to add at least 100 milliseconds of round trip time for each API call. If your backends are in Perth as well, then you can probably add another 100 milliseconds to that too. So for some businesses that have very latency sensitive data, then certainly that 100 millisecond round trip time could be too much. So location's a very important thing. Resiliency. So certainly that's another reason why people go on premise rather than cloud. And people tend to look at cloud and go, hey, look, they never go down, right? Well, that's not actually the case. As a matter of fact, here are just a few articles that I pulled from doing a Google search just in the last few months. And we can see here that every single cloud, doesn't matter whether it's Oracle or Amazon or Microsoft or Google, but every single cloud over the last few months has suffered some kind of outage. People in Australia probably remember the outage that happened at the end of August, start of September with Microsoft. So clouds aren't immune to having outages. And certainly that's another reason why people put it on-prem. The last one, it's a bit of a hot topic, and that's political. So perhaps you've said the wrong thing on Twitter or X or whatever it's called nowadays, and suddenly you've got a swarm of people wanting to deplatform you and make you persona non grata. Well, this cancel culture thing is certainly growing and growing, and so people are looking as well to be anti-fragile and move away from these cloud operators because what we have seen in the media is some of these Some of these businesses do get shut down off clouds or off DNS providers, or even their bank accounts shut down as well. And I think as we move into a more political and socially fractured structure as well in society, then this will probably come up more and more, and that might encourage more people to move on premise. So now that we've got that out of the way, it's probably worth understanding how to build API platforms in the enterprise. Now, if none of you have built applications or large platforms in the enterprise, it's worth understanding how hard it is to be able to get the traction on that. So if you look at the enterprise, just never underestimate the weight of that. When we look at building an application at home or an API platform at home, we can get from start to finish very quickly. Like, you could probably get an API platform on premise on your home up and running within less than 30 minutes. So when we look at the small business side of things, it's going to be not as quick as doing it at home, but it's certainly going to be pretty quick. Putting an API platform on a pre-existing server, maybe that's sitting on under someone's desk, but it's going to be pretty quick. But in the enterprise, to get from start to finish, well, projects take a very long time, and some tasks are measured in months, projects are measured in financial years. And so even if it looks very quick, don't underestimate the enterprise beast. So what I'm saying there is, if you've looked at the documentation, if you've looked how quickly it is to be able to launch and deploy things either in the cloud or on premise, you need to probably add a factor of 10 to that when you're building in the enterprise. Part of the reason for that are things like Conway's Law, where the systems that get designed tend to get designed around the organizational structure. And so you have network, application, integration, and infrastructure teams. And then you have a group of people like project managers, architects, engineering leads, product and platform owners that are the glue to holding those people together and getting those things done in a concerted manner. Of course, there's other challenges in the enterprise as well, such as approval cycles, testing coordination, technology readiness. There's design pivots that happen as you uncover things during the build. And then there's inherited limitations of the enterprise business as well. So keeping that in mind, let's now move on to the on-premise API platform experience. So we'll give you the ins and outs now, the tips and tricks from our build experience for building with this large client. We won't mention the client per se. I will mention the technology we used. I'll try and make it as generic as possible, but we used Azure's API Management Gateway, or the self-hosted gateway, which is their on-premise version of their API gateway. So let's have a look at the problem statement first. So what we were asked to do, well, of course, build an on-premise API platform. This was also an extension to an existing API platform this enterprise had on the cloud. So this was a hybrid platform, not a complete greenfields build. It had to run active-active. So we're talking about 2 sites in 2 different states running these API gateways on premise in an active-active mode. It must survive a total cloud outage. So if the clouds are out, then this platform must stay up and running. So this must mean it has to stay up all the time. Yes, all the time, or well, perhaps 99.999% plus all the time. So this is a very mission critical infrastructure that we built. It has to stay up all the time, even if the power goes out or there's natural disasters. The expectation is that these APIs will still be running. So that's how important this platform was that we built on premise. So everything had to be on premise capable in case of those outages. So the image registry, metrics, logging, code repo, etc., not just the API platform itself. So keeping that in mind, let's have a look at the timeline for delivery. So we started on the 4th of July, and we had to launch in less than 3 months later on the 1st of October. So already that's a very compressed time frame for delivering in the enterprise. So the design time frame building a design out for the two-site on-premise API platform. Took around 6 weeks. We had early access to a sandbox during that design period, which was critical for us. Building 5 environments on 4 OpenShift clusters across 2 sites. That took us around about 6 to 8 weeks. Then going into test, overlapping with the build, that took us all the way from mid-August up to near the end of September. And then after the test period, we got a green light to launch into operations a week before the 1st of October, which is the date we went live. So we actually hit the delivery date. So let's have a look at the some of the learning and the tips and tricks here. The first thing is, for a project like this, building an on-premise API platform, it's really a 5 to 6 month project. So if you're a project manager, definitely factor in 5 to 6 months. For the API platform part itself, you really need 2 dedicated people that are cross-skilled. So they know about API platforms, how to build APIs, networks, they know Kubernetes, and other bits and pieces of the technology to get a successful outcome. So 2 dedicated people to build that platform. Make sure that the architect and the designer, that was me in this case, also builds the platforms. They're also one of those builders as well. Then they're sipping their own champagne and they can go back as they're building and retrofit the design as needed. One of the really important things for us to be able to get this done in a crunch timeframe, as soon as we were told to build this platform, the very first thing we did was we stood up a sandpit environment in Sonrai. We built our own API management gateway, our own Red Hat cluster, and put Appium self-hosted gateway on top of it right at the start. So then we had a good environment for us to be able to tease out and look at what design factors and what build factors we needed to think about as we got into the design and build. Even early on in mid-July, we were handed over a dev OpenShift cluster in the customer's environment, and that allowed us to really get started and accelerate it quickly. And lastly, make sure that your builders, the people building, are going to operate. Again, it's that sip your own champagne type mentality, that they're not just throwing a dead cat over the fence. All right, so now let's have a look at the solution overview. So we'll take it from the top. On the left-hand side, we've got the Azure cloud and the existing API management gateway. And then on the right, in that green box, we've got the new self-hosted gateway. We've got the API clients up the top. The blue line represents the existing API connections into the public API gateway. The orange line represents the new connection into the mission-critical APIs. The red line is the communication from the runtime, the self-hosted gateway, to the cluster. And then the purple line there is the DevOps communication. So it was an internet-facing gateway for mission-critical APIs. So it was important to make sure that we could plumb the internet securely and safely into the on-premise data centers. We also had to think about the management plane connectivity. So this is a hybrid solution. So that means that all the configuration is done in Azure API management. And this is the same for other clouds like Google's Apigee hybrid infrastructure as well, that all the API updates, heartbeat and telemetry also gets communicated to and from the management plane. Thinking about Azure DevOps as well, the YAML, the manifest, and the config, where that's going to live. And of course, we've got the existing internet-facing API connection as well, and making sure we weren't accidentally routing that traffic through to the self-hosted gateway. So let's dive into the physical infrastructure now. We had 4 OpenShift clusters we were building on. 2 of those are VMware-based clusters, and then 2 of those for the production environment were physical servers that were built and installed in each of those data centers. And so thinking about physical infrastructure, if you're looking at on-prem, there's a number of things you need to think about. One is physical infrastructure delivery time. Look, today's supply chain issues aren't as bad as what they were back in 2020 to 2022, but it can still take a number of months to be able to get servers, network equipment, and storage into your data center. So factor that into your timeline. Data center space. Look, this is something that does get overlooked. People assume that there's enough space in their racks, but before you start the project, get out there, have a look at the racks, see if there's enough space in there if you need to purchase and install any equipment. Network capacity. This is another thing that can cause people to get unstuck. And certainly this actually caused us to become unstuck a little bit, in that the Brisbane data center didn't have enough network ports available at that point in time. And that was only found out as we were going into build. And so a secondary environment that was planned to be built in Brisbane didn't actually get built there instead. And we resolved that just by having a non-production environment in Sydney. Matchy. So the more critical your infrastructure, the more that you want your lower environments to match production, even down to the infrastructure. Trying to get that obviously is up to the budget of your project. Obviously, the less important the infrastructure is, the less matchy it has to be. But going all the way from infrastructure all the way up the stack to the application, trying to get that to match as closely as possible will certainly help as you shift your versions from dev up to the higher environments to production. So let's have a look at the Kubernetes deployment. And we're actually going to have a bit of an Easter egg at the end of this, where you can download, there's a bit of a QR code, and you'll be able to download a lot of this information from our Sonrai developer portal. And we've got some sample deployment manifests there for you to download if you want to download those. So again, we're looking at 4 different clusters that we had to build across. 2 of those were our physical production clusters in Sydney and Brisbane. And we tried to make sure that we matched the environment as closely as possible to each other. So as we were progressing from our dev cluster up through to production, it was a fairly seamless approach getting from one to the other. But some tips and tricks when you're looking at Kubernetes deployment for your API platform, you got to be careful of code drift or config drift as you move through to the high environments. Now, we were dealing with an on-premise API gateway. We didn't have that connectivity back into Azure DevOps or back into pipelines. And so at that point in time, we were manually deploying up from dev through to production, which leaves it a very high risk for code drift. And so before going into production, we had to come back and make sure we normalize that code across the environment. But the longer that you leave that, or the longer you stay out of that CI/CD and that pipeline type of delivery methodology, the more and more your code will drift. So certainly something to keep in mind. Deploy as soon as you can and deploy in dev. That's the other tip. We got access to that that sandpit environment. It's always worth making sure that you build as you're designing. Bring security on the journey. If you don't, you can find that they can make some fairly dramatic changes to you as you're building. We were planning to put non-production on the production environment. Security came out and said, no, we want that completely segregated. And so we had to build a new environment. So that's how design changes can happen if you don't bring the right people on the journey. And you can see later for the sample manifest deployment. We'll show it a later time. So let's have a look at the network access now. We'll just have a look at the external network access. This was also available internally. Only the non-production and the production clusters were available to external access. We'll just zoom in here on the front end access and just go through this a little bit with you. So looking at the load balancer side, we had the load balance across Sydney and Brisbane. Thankfully, the API gateway provided a fairly good status endpoint out of the box to do that health check with. And so we used that as our status to see whether those clusters were up and running. With ingress and into the OpenShift clusters, we used ingress sharding, and we segregated the environments via dedicated ports. And so making sure that we were only routing traffic to those specific ports for that ingress controller, for that namespace. That was an important part of making sure the traffic was going to the right location, and we kept that traffic segregated and secure. Putting in place OCP routes or ingress in Kubernetes to route the traffic to the right APM instance based on the URL in the request. So there's a couple of things you need to look out for there. If you're doing SNI injection from your F5s or your load balancers, you've got to be careful how that gets picked up in your deployment, particularly your ingress controller, and how that traffic gets routed to your deployment. So a couple of tips: load balancing across nodes and clusters. Understand how you're going to do that and try and test that as early as possible. Ingress sharding, I recommend that if you're going to be deploying. Definitely shard your environments. Be careful of SNI tagging, as I mentioned before. As those SNIs are brought through from your load balancer, they'll get picked up by your OpenShift environment. Routing traffic is quite complex, so you need to spend a fair bit of time on that. Let's have a look at security now. So this is an example diagram of the environment and how the network security. I'll only go into network security. There's lots of different areas of security we can go into, but I'll only go through network security here. But certainly segregating your environment is of critical importance. You may want to share those clusters with different workloads, and so making sure they get segregated is important. Ingress sharding is how you do that primarily, but also using network policies as well to be able to make sure you only allow certain traffic from each namespace or each OpenShift project to see each other. Egress IPs, dedicate egress IPs per namespace, so what's coming out you can firewall. And then you can apply those firewall rules both inbound and outbound. There's actually a good red paper out there by IBM, red paper 5641. So that was a great red paper. Definitely worth investing some time reading that if you're looking to deploy good network security on your OpenShift environment. So when we look at that from a network perspective, what we have here is both the production partner.api.prod.com.au and the pre-production partner.api.preprod.com.au coming into the one OpenShift cluster. Of course, we actually segregated that out to separate clusters, but if you did want to employ different applications, two different applications on the one cluster, this was how you would network secure that. Making sure that the F5 is routing to particular URLs and those unique ports on the ingress controller. Obviously, the ingress controllers route traffic to a particular namespace. They're waiting on a particular port. The namespaces themselves have network policies to prevent that cross communication. Then you have dedicated IP addresses per namespace to allow that firewall segregation. So lastly, I'll touch on operations, our operational build for this on-premise platform. So you've got the cloud metrics, so local telemetry as well as cloud telemetry. But for local telemetry, we implemented a StatsD Prometheus deployment. So then we had an OpenShift route that our operators could use to get local telemetry. So a couple of things when deploying local metrics for local telemetry. It's important to build, in this case, we built both. So you can get it on the Azure user interface as well as locally through Prometheus. For Prometheus, the time series database, make sure that's on a PVC, not on ephemeral storage. So when you need to reboot or you blow away Prometheus and bring it back, the time series database is still there. Set resource limits. So Prometheus can spin out of control. Sometimes it's been known to do that and chew up all the RAM and CPU. So make sure you set resource limits on Prometheus so it doesn't impact your production workloads. And now looking at local logging. So we used Filebeat. For OpenShift, there is native cluster logging. We would recommend that. But for our client, they used Elk and Filebeat. So we used Filebeat deployment in this case. We deployed Filebeat as a daemon set across the nodes. In this case, production. We're looking at 3 nodes in Sydney. It looked at the container logs, and then it shipped those logs through to the Logstash instance. So when deploying Filebeat, especially to OpenShift or other clusters, it needs privileged permissions to look at those container logs. So that's something you probably need to talk to security about. Then you have to concern yourself as well with indexing, dissecting and parsing those logs. Probably best practice to do that in the Logstash side rather than the Filebeat, but you can do either or. And then, cluster logging versus Filebeat. Would always recommend going with the native out-of-the-box cluster logging solution than Filebeat. So all these manifests are available. You'll be able to download them as well as example manifests. You'll be able to deploy a fully self-managed gateway in OpenShift once we see that QR code. So let's have a look now at our go live and how did we go with building this platform. Well, before the 1st of October, so before 10 a.m., 1st of October, we were in a pilot mode for a week with traffic coming through from a few pilot API users, and that was fairly steady. And then as soon as it hit 10 a.m. or 11 a.m. Australian Eastern Standard Time, it was go live and it was switched on. And we can see there that the second cluster started receiving a lot more traffic. Now, since that point in time, we've had, I guess, since last Friday, we've had over 500,000 API calls just in a few days come through to the platform. And we've only received 32. We've only had 32 500 errors from both clusters from the platform. So that's over a 99.99% success rate with traffic. So it has been largely a success, which has been great. We have been able to build this platform active across both sites. And lastly, if you want a copy of this presentation, a full example, detailed design of Azure Apium self-hosted gateway on OpenShift, the Visio diagrams, and example YAML manifests, just scan the QR code and it'll take you to a page. It'll take you to our developer portal, sign in, register, and then use the Postman collection to download away. Well, thank you for listening. Hopefully you got a lot out of this talk on how we went about building an on-premise hybrid API platform. And best of luck and enjoy the rest of the talks at API Days. Thank you very much. Enjoy your day.